Dear friends, once again, welcome to all of you. Today we are going to the last part of the chapter Strength of Organic Acids and Bases. And today we are going to discuss the heterocyclic bases and acid and base catalysis. First of all, heterocyclic bases. In the heterocyclic bases, nitrogen is a heteroatom and the simplest heterocyclic bases are pyridine and pyrrole. First of all, we are going to explain the base strength of pyridine. Here, pyridine, the pKb value of pyridine is 8.96. If we compare with the aliphatic bases, and the example of aliphatic bases, methylamine, the pKb value is 3.36. Too much difference is there. The pK value is high of pyridine. Why this is so? Means here aliphatic bases are stronger base than the heterocyclic base pyridine. Now why pyridine is a weak base? This is because here the non-bonding electron pair on the nitrogen is tightly bound and the nitrogen atom is sp2 hybridized. So availability of electron pair to donate chances becomes decreases. So the pyridine is a weak base. Now the another heterocyclic base, pyrrole. Here if we consider, if we compare the pyrrole and pyridine, the pKb value is 13.6, means it's very weak base than the pyridine. Now why this is so? Here the non-bonding electron pair on nitrogen is delocalizes in the ring and it complete the aromatic sextet of electrons. So availability of this electron pair is decreases and obviously the base strength decreases. Here the non-bonding electron pair delocalizes and it complete the aromatic sextet of electrons. Here in the second example, pyrrole, if pyrrole is protonated, then there is formation of this intermediate, this conjugate acid. Here this intermediate is less stable because its aromatic character get lost and the positively charged nitrogen attached to sp2 carbon. That's why from these two reasons we can say the pyrrole is a weaker base, or pyrrole is the weaker heterocyclic base. Now suppose pyrrole in presence of strong base accepts the proton and the proton from the pyrrole is easily donated to base and forms it acts as an acid and forms a conjugate base, and the conjugate base gets stabilized by resonance. So and aromatic character also not lost in this case, so this clearly indicates pyrrole acts as a acid in strong base. After complete hydrogenation of pyrrole, there is formation of pyrrolidine, and if we compare the pKb value of pyrrolidine, it's very less as compared to the pyrrole, because here the non-bonding electron pair is easily available to donate H plus, and hence it is a stronger base. Now the next and last part of this chapter, acid and base catalysis. Now organic reactions are catalyzed by acid or base, and the typical example is esterification and aldol reaction. Suppose the esterification reaction, acid. Here in presence of acid catalyst, the carbonyl oxygen accept the proton, means the acid get first protonated in acid catalysis, and because that what happens, the carbonyl carbon acquires a positive charge and attack of nucleophile becomes more easier and the reaction get faster. Then afterward the proton transfer to form a good leaving group, and finally we get the ester is converted into acid. So esterification of acid by the acid catalysis becomes very fast. Now both acids and base catalysis occurs in two different ways: specific catalysis and general catalysis. First of all, we are going to discuss specific catalysis. In the specific catalysis, here suppose the example ester hydrolysis. In presence of strong acid, that is ester first of all gets protonated, and this happens before rate determining step, and such reactions are generally called specific acid catalysis. This reaction generally very strong acid is used. Here in specific acid catalysis, reactant or intermediate is fully protonated prior to rate determining step and forms the intermediate. Okay, here proton transfer, good leaving group is formed, and finally ester get converted into acid by using the strong acid. Such a reaction are the example of specific acid catalysis. Now the next example, general acid catalyst. Here ester hydrolysis, again by using the acid, but here acid is a weak acid. Then in such case the attack of this nucleophile and protonation of ester is simultaneous, and it is occur during the rate determining step. And here again formation of transition state. You know, in the transition state, bond breaking and making process is simultaneous, and finally this ester get converted into acid. Here the use of very weak acid, so such a reaction are generally referred as a general acid catalysis. The difference in a specific acid catalysis and general acid catalysis: in the specific acid catalysis, protonation first before rate determining step. In a general acid catalysis, protonation and attack of nucleophile is simultaneous, and in a specific catalysis strong acid is used, and general acid catalysis, a weak acid is used. Now the next part, specific and general acid catalysis. Part here we can represent by using the graphical representation. Here we know in the specific acid catalysis there is formation of intermediate, because protonation is first, and then afterwards it gets converted into a product, but it requires a strong acid. Here the transition state, protonation as well as attack of nucleophile is a simultaneous process. Transition and the bond breaking and making process is a simultaneous. Here the reaction is carried out in presence of weak acid. Now the next and last part of this chapter, specific base catalysis. Here the example of conversion of cyanohydrin to ketone. Here the reaction is hydroxide catalyzed, base catalyzed. In this specific base catalysis, here again use a strong base, and the specific base catalysis reactant is fully deprotonated, and it is before rate determining step or prior to rate determining step. Very similar to specific acid catalysis. Here deprotonation. In a specific acid catalysis, there is protonation. Itself protonation occur in a before rate determining step. And same here, there is a use of a strong base. Okay. And finally, this is the formation of ketone. Now similar in the general base catalysis. Here the example of ester hydrolysis by using triethylamine. Here in general base catalysis, proton transfer from reactant or from the base, it is takes place during the rate determining step. Here partially proton transfer to base and a transition state, and this reaction is carried out in presence of weak base, and finally this ester gets converted into acid. So if we have finished the chapter, thank you very much.